Additive biomanufacturing technologies such as melt electrospinning writing, or MU, are at the forefront of tissue engineering research. MU is a technology that enables scaffolds to be fabricated that exhibit highly defined, micrometer to submicrometer features. However, the fabrication of large volume MU scaffolds for soft and hard tissue regeneration remains a challenge. In their paper in Advanced Materials, Professor Dietmar Hoopmacher and colleagues from Queensland University of Technology and the University of Würzburg provide an understanding of the electrostatic interactions that currently limit scaffold size in MU and overcome these limitations with a mechatronic system. Computational modeling of the MU printing environment was undertaken, where voltage was either kept constant or altered to maintain constant electrostatic forces. Moreover, the distance of the spinneret to the top layer of the scaffold was kept constant. 5 different MU scaffolds were produced to experimentally validate the simulation findings. Due to electrostatic repulsion attraction phenomena, distortion events such as random fiber placement, polymer beading, and spontaneous fiber ejection back toward the spinneret were observed. The C1 scaffold was used in cell seeding experiments to illustrate that these large volume MU scaffolds support cell attachment, migration, proliferation, and extracellular matrix formation throughout the scaffold volume. To find out more about how to achieve these highly ordered large volume MU scaffolds, please visit the Advanced Materials homepage.